Okay, so we're going to be doing 2.8, solving inequalities in one variable. One variable. All that means is when you look at this, there's only an x. That's all it means. Inequality. So as you can see, these are going to be exactly like the other ones, except there's an inequality sign instead of an equal sign. All right? Here are the steps. First, you want to factor the polynomial. Pretty nice because it's already factored for us. Set the factors equal to 0 to find what we're going to call critical numbers. All right? We're going to set up the number line using the critical numbers. Do that right down here, and I'll get to that. Show the signs of each factor in a sign chart on the number line. That's going to be right down here. We'll go through it. And write the solution to the inequality using interval notation. We're going to put that down here. So, walk you through step by step. Ask questions along the way. If you need me to slow down, please ask me to. Okay. Set each factor equal to 0. X plus 3 equals 0. So what does that mean x equals? -3. Yep, you got it. -3. So, one of my critical numbers is -3. We set the next one, x squared plus 1 equal to 0. Okay, let's subtract 1 first. What do we get when I take the square root of -1?
I.
We do. We get that imaginary I. Okay, so this is going to say plus or minus the square root of -1, basically plus or minus I. Because it's imaginary, we're not listing it as a critical number. So it gets saved over there and we don't worry about it. Okay? The next one, x minus 4 squared equals 0. Oh, back to this. No matter what value I put in for x, will that ever equal 0? No. Will it ever be less than 0? Could it ever be negative? No. And the biggest reason is because it has an x squared in it. This x squared makes every number positive. I don't care what number you put in, it always is going to make it positive. So it will never be 0 or less than 0, which is why it came out imaginary. Okay. Take this one, square root both sides. Still get x minus 4 equals 0. So that means that x equals what? 4. That is my second critical number. Now, when they say to use a number line, whatever your critical numbers are, you just put them on the number line. Don't worry about the spacing. Don't worry about the fact that, oh, that's maybe not technically how far apart they are. Just make sure that they're in order from smallest to largest. Where do you think they got these parentheses things from down below?
From above?
Yeah, they got them straight from here. This is the first one. That's the second one, the third one, and that's what they are. Okay, so now what we are going to do is we have to test numbers. All right? Think of a number less than -3. Yep, -4, fine. If I put -4 in right there, will this end up being, and you don't actually have to do the math, you just need to have an idea, will it end up being negative or positive? It's going to end up being negative, so you put a negative right there. And actually, any number less than -1, I could have put -5 in there, I could have put -10. It doesn't matter, it will always be negative. Does that make sense to everyone?
Yeah.
Okay, the next one. Yep, go ahead, Blake.
No, wait, never mind.
All right, so right here, we're going to test -4 again. If you square -4, will it be positive or negative? Positive. So this thing right here is always going to be positive. So we put a plus there. Okay, now I put -4 into here. What -4 minus 4 is going to give me, negative or positive number? That should be negative. Okay, we'll get to that point. Now we're going to go to this one. We'll worry about this later, but right now we need to get to here. what's a good number between -3 and 4? Let's just use 0, okay? Because that's nice. So if I put 0 in here, will that end up being positive or negative? 0 in here
positive,
and 0 in here.
negative.
Okay, good. All right, move to here. Let's use 5. All we need is a number larger than 4. If I put 5 in here, it is
Positive,
5 in here and 5 in here. Okay, so now, does not matter what the numbers are. If I if I square a negative, it will always be what?
positive,
Positive. This will always be positive. That will always be positive. Okay. What if you take a negative number times a positive number times a positive number? What kind of a number will you get?
A negative number.
You will get a negative number. So this is going to be negative. Okay? So what that means is this interval right here is going to be less than 0. All right? And we'll get to the solution in a minute. What if you multiply a positive times a positive times a positive?
positive,
Positive times a positive times a positive?
positive,
Okay, so it looks to me, we want to know when this polynomial is less than or equal to 0. It looks to me that it is going to be less than or equal to 0 from negative infinity to -3, including -3, because I want to know where it's equal to. Does everybody see what we kind of did there? There's a process, and it just helps to find a solution. Okay? Now, double check. Okay? Let's say that I want to make sure that I did it correctly. Well, what I can do is I can actually take this equation here and type it into my calculator. And what do I have? X squared plus 1. And then we have, and graph it.
You didn't put the squared on the end of it.
Oh shoot, I didn't. You're right. Okay, now I have to go. All right. Thank you for telling me that.
That's right.
Go back to here. I need to put it on the outside there. There we go. Okay. So now, okay. And if I were to zoom out, you can see oh, that's really tiny. Shoot, I would rather not have it that way. Okay, so if you look at this graph, okay, what we're going to see is that it is negative or below the x-axis from -3 all the way that way to infinity. It's underneath the x-axis. It's positive up here. But what do we notice happens right there at 4? What does it do at 4?
it touches,
It does touch. So do we need to include that because we need to know when it equals 0?
Yeah, you could do union in a
I could do union and then just go like this.
4.
I could do that. Okay?
Hey,
All right. Okay. Here we go. Turn the page. Oh, great. Now, guess what they did not do? What did they not do in this one?
they didn't factor in.
They did not factor it. Okay. So what I have to do is I've got to figure out if there's any roots in this. Okay? You could do you guys remember the rational root theorem? P over Q? Okay. P is 24. So that would be factors of 24 divided by factors of 2. Well, that looks to me like it's going to be plus and minus 1, plus and minus 2, What else goes into 24?
12 and 2.
Okay, so we have a lot. So our possible rational roots are 1, and then 1/2, 2 over 1, 2. 2 over 2 is 1, so I'm not going to count that. 3 over 1.
Do you really have to do this?
Well, I know, it seems like this would take forever, and so on. What's another way we could see where it crosses, so we can make our factors? We could what?
Graph it.
We could graph it. Would you rather do that?
Oh, yeah.
All right, well, let's type it in and see what we get. What's the most number of times that this could cross?
3.
3, because it's a cubic. And what's the least number of times it could cross? Once, because it is an odd-powered function. Okay, where does it look like it crosses on my graphics? Where's that? Yep, okay, if I go to my table, we see for sure at -2 and at 4. So we know that 2 critical numbers are -2 and 4. And I need a third one. I don't know if that goes, halfway or not. So what we're going to do, okay, I've got a lot of space, so we're fine. Right now, I've got 2x cubed minus 7x squared minus 10x plus 2. It equals x plus 2, because if it crosses at -2, then it's x plus 2. And x plus 4.
Wouldn't that be minus?
Oh, it is minus, thanks. I've got 2 of them. How can I find out the leftover part? How would I do that?
Synthetic division?
Yeah, let's do that. And that's not too bad. So let's go -2 over here, and we're going to do 2, -7, -10, 24. Okay, should come out 0 because it's a factor. So now I'm going to divide this leftover stuff by 4. So what is left over? What does the 2 and the -3 represent? I started with a cubic. This is x to the 3rd. So then this became x squared. So what does that become? Just x. So that means the leftover part is 2x minus 3. Okay? So now my critical numbers are -2, 4, and what's this one?
-3 over 2.
Positive 3 over 2, because it's opposite. All right, so let's put them on our number line. Which one goes first? -2, and then 3 over 2. If you want to write 1.5, just so you understand, that's fine, I don't care. And then the last one is 4. Okay. All right, here's our first one. What number should I test?
-3.
-3. Okay, if I put -3 in the first spot, what is it? Okay, negative 3 in the next one,
Negative,
and negative 3 here.
negative.
Good. What's a good number between negative 2 and 3 halves?
0.
0. Yep, I like using 0, it just makes it easier. So if I put 0 in here, it is positive. 0 in here,
Negative.
0 here.
Negative.
Okay, let's move to the next one. A number between here and here, 2?
Yeah.
Sure. Okay, put 2 in here,
Positive.
2 in there,
Negative.
2 in here.
Positive.
Okay. What number you want to test here?
5.
Okay, 5 in here,
Positive.
5 in there, positive and positive. All right, is everyone understand how I got, Jacob, everybody get how I got those plus and minuses? Okay. Now, when you multiply 3 negatives together, am I going to get a positive or negative?
Negative.
It'll be negative. What about when you multiply a positive times a negative?
Negative.
And then a negative times a negative?
Negative. Positive.
Yep, that's going to end up being positive. And what about this one? And this one? Is there a quick way to just write negative and positive? Oh yeah, no. What I'm saying is there a quick way to just look at that and know if it's negative or
It
positive?
has 2 negatives in it.
Okay, if it has an even number of negatives, they're going to cancel each other out and they will be positive. If it has an odd number of negatives, it's going to be negative. This had 3 negatives.
Oh, that's true.
2 negatives, positive, 1 negative, negative, none, positive. Now, what are we looking for in this problem? We want to know where the problem is what? Nope.
Greater than.
Greater than 0.
Okay, not equal to, but bigger. How many intervals are greater than 0? 2. From negative 2 to 3 halves, and 4 to infinity. Yes?
Like for the positive and negative thing,
Yeah.
the second one, there's 2 negatives, why is it constant?
Because like if I say negative 2 times negative 3, you're going to get like a positive 6.
Oh.
And then, yeah, so whenever you have an even number of negatives, it'll always be positive. Because they just get multiplied. It doesn't matter what the numbers are. If they're 2 negative numbers, they'll always become positive. Okay? Good question.
Why is the solution not?
Go ahead. Alex,
Why is the solution not? Like, I don't understand how you got that.
how I got this?
Yeah.
Those are the intervals that are positive, and I need to know where this function is greater than 0, which means where it is positive.
Alright.
Okay? That symbol tells us ultimately how we're going to read this is called a sign chart. Okay? Okay. Oh wow, what did they do in this one, guys? They got fractions.
I want to die.
No, not yet. You have a long life ahead. Here we go.
Oh.
We'll do a couple more, then we're going to take a break, okay?
Alright.
Okay.
Wait, like an accident.
Now, in this particular case, the zeros of both the numerator and denominator are critical numbers for sign charts. So, both numerator and denominator. What gives us a 0 in the numerator?
-1. Yeah. Oh no.
Nothing. Yeah, nothing. Nothing.
Nope.
That's real tricky.
A half.
Yep. -1/2. Okay, what about right there in the denominator? What gives me a 0 there?
-3 and
Yes, -3, +1. Good. Now we're going to put those on my number line. Which one goes first?
-3.
Okay, then, and then 1. Okay, now, do you notice they always set up your sign chart so that there's parentheses for each section, and this time they made the line to show the fraction. But we're still good. We're still gonna, put stuff in and do all of that. So here we go. What about the top? Let's try -4. If I put -4 in there, what am I going to get? Negative. -4 right there. And a -4 there. Negative. Okay, moving to the next section. Give me a number between -3 and -0.5. Negative 1 or -2, either one. If I put -1 in right here, what would I get? It would be negative. -1 right there. Okay. And -1 right there. Negative. Okay. What about between -1/2 and 1? What's the best choice? 0. Yep. So put 0 in the top. Positive. 0 right here. 0 here. Okay. And then the last one, let's put in 2. All right? 2 up there. 2 right there. And 2 right there. Okay, let's use, you know what? It doesn't matter if it's division or multiplication, guys. We're going to use the same rule. If there's an odd number of negatives, it's negative. And if there's an even number of negative, it's positive. So, this first section is what? Negative, then it's... Now, you might be thinking that it always alternates, and it does not. So you have to be careful. Bless you. It sometimes does, sometimes doesn't. What are we looking for in this problem? What are we trying to solve where it is what? Yep. So which intervals are less than? Infinity to... Yep, including it. Then we're going to have to union -1/2 to 1. Okay? All right, we're going to take a little break right now, and we will come back to that one.